Hi, this is James Page for ECOC TV. We have another guest with us now after the market-focused session today, and that is Chris Pfistner from Avicena Technology. Chris, thanks very much for joining us. I thought it was a fascinating statistic towards the end of your talk, looking at just what the energy consumption needs will be for data centres in the future, which particularly made the case for trying to reduce energy consumption at the interconnect. But it was it's a big issue for us to try and tackle.
Yes, so data centers are projected to consume about 10% of the world's energy by 2030. And a big part of that is just interconnects. So it's processing and it's interconnects. If we can reduce the energy of either one, that will be a big deal. It will be a big deal for all of us.
And we've heard a lot over the last day or so about the benefits of silicon photonics. Is that what you think is going to solve all ills?
It's a good question, and I would say silicon photonics will definitely solve some of our problems, but not all of it. And specifically, silicon photonics is good for longer reaches, up to 2 kilometers, reaches above about 10 meters. When you go below that, which is what's needed for chip-to-chip interconnects, then we're looking for another technology. And one candidate there is what we're working on right now, which is LED-based links.
Well, perhaps you could tell us a little bit more about that, and specifically the light bundle product. What are its sort of key benefits?
Sure. So just for everyone, light bundle product is our LED interconnect, and because it's an LED, fundamentally what LEDs are is they are not lasers. Lasers need to be brought over threshold, so they need a minimum current before they start to emit light. LEDs with very little current, they basically emit light because they're not lasers, they're just a light source, a standard light source, and that makes a huge difference. Now on the flip side is LEDs the reach is about 10 meters for practical use, whereas lasers can go much further.
Okay, great, thank you very much. I noticed at the start of your talk there was an interesting sort of aside about Moore's law, which I know is important to Avicena, and you were suggesting that if it's not dead, it's definitely slowing down. Do you think that's a problem? Do we need to speed it back up?
Well, so yes, it is a problem. It's a problem for the semiconductor industry. But since we're hitting physical limits, fundamental physical limits, or physics limits, we can't really speed it up again, so we need to get smarter on how we build future computer systems. For a while, we used to be able to just improve the processor performance about 50% every year. The same footprint, same energy consumption, same cost, often lower cost. That's no longer working, so now we need to figure out how we can link different chips to do the same job on a cluster of chips rather than one super chip. And that's where the need for a really efficient interconnect technology comes in, and that's where LEDs can really make a difference.
Fantastic. Well, thank you very much for explaining that to us. I hope you have a great conference, and I'm sure we'll see you around on the exhibition floor at some point.
Well, thank you for having me, and you the same.